All right, today I want to talk to you about this question from your 5-2 review we did last week. This was a doozy of a question, and you are going to need to do something similar to this on next Tuesday's open note test. So watch this video, take good notes, even like write notes to yourself on the side on what steps to do and why did we do this, and use Post-its or whatever. Use a full sheet of paper for this one, okay? I promise it looks worse than it is. If you're comfortable with SOHCAHTOA, you can do this problem, okay? Now notice it's a weird shape, and we've already put a dotted line over here. I'm also going to put a dotted line on the right side, and on your test on Tuesday, you're going to see those dotted lines, okay? And the first thing I want to do is notice that this angle was 120 degrees, but when I drew this line in, that means this side is 90, which means the remaining is 30 degrees, okay? So now I have a triangle on the left, a triangle on the right, and a rectangle in the middle. I'm going to have to figure out, in order for the area, I'm going to need base and height, base and height. Lots of you guys got the rectangle right. I was happy to see that. You were like, okay, this part's easy. Angle or area of a rectangle, base times height, 30 times 10. That's 300. 1 dash means feet. So 300 feet squared for the area of just the rectangle. That part's out of the way. We also have to find the area of this triangle on the right and the one on the left. On the left, we do know the base is 2, and we have to find the height. Here, I'm going to redraw this right side triangle. So on the right side, we know it's a right angle, we know this is 30 degrees, and we know that this whole side, okay, this is 2, but remember this is a rectangle, so 10, 30, this is 10. So this whole side up and down is 12, okay? This whole side up and down is 12. So now that I know 12, I can certainly find the bottom and the hypotenuse using SOHCAHTOA and or Pythagorean theorem. The triangle on the right side, I'm going to redraw. Okay, they tell us this is 85 degrees. They tell us the bottom is 2, so I can find the right side and the hypotenuse. Okay, so I redrew some triangles here. I'm just going to put this here so you can see we're going to work with these triangles. If I want to find this side, it is opposite. And I didn't write this down, but based on the picture, there is a right angle there. This is opposite across from the 85 degrees, and this one helps form the 85 degrees, so this is adjacent. So my first thing I'm going to do to use opposite and adjacent is tangent of 85 degrees is equal to, we don't know, I'm just going to put an X there, over adjacent, which is 2. Okay? If I put this over 1 and I cross multiply, I get x equals 2 times the tangent of 85. So on my calculator, mode, degree, I'm all good. 2 tan 85. I get 22.86. X is approximately 22.86. That's for this whole entire right side. Okay? Now, once I know 2 sides of a triangle, and I know it's a right triangle, I can find the third side using Pythagorean theorem. So, I'm just going to keep on going down this page. I'm going to say 2 squared plus 22.86 squared equals, and I'm going to call it c squared, the hypotenuse. Now, I already have this 22.86 in, so I'm just going to hit squared plus 2 squared equals, okay, so 526.58 is c squared. So to get c, I'm just going to take the square root, and that is 22.95. Okay. If you rounded and you use the rounded answer, you'll get an answer pretty close to mine. You'll get, you actually get the same thing, 22.95. Okay. So this side is 22.95. So we got that triangle down. Let's go back to our original picture and see how that's helpful to us. So the 22.95 is going to be helpful when we're finding perimeter. Now this 22.86 is the whole entire thing here, okay? If this piece is 10 and the whole thing is 22.86, if I do 22.86 minus 10, I'm going to get 12.86 just for this little piece here. So the 22.86 helps for the area. The 12.86 will help for the perimeter. While I'm thinking about it, we already have part of the area. The area of this triangle right here is base times height divided by 2. Okay, and when I plug that into my calculator, I'm just going to get 22.86 square feet. Okay, so I have 2 out of the 3 parts for area. Okay, let's go ahead and figure out the bottom and the side for this triangle to help me with both area and perimeter. On the right side, okay, I have 30 degrees, and the 12 is not the hypotenuse, it's not the longest side, it's not across from the right angle, but it does help form the 30. That is adjacent. Okay, so I could use opposite and adjacent to help me find the bottom. So again, I'm going to run out of space, kind of. So, katoa, I should have written that to start with. Anytime I'm using opposite and adjacent, toa is my choice. Opposite and adjacent, I'm going to use toa again. You could have used cosine to help you find the hypotenuse. Okay, so tangent of 30 degrees is equal to opposite, we don't know what that is, I'm just going to call it y, over adjacent, 12. And again, turn it into a proportion, cross multiply, y is equal to 12 times the tangent of 30. So on my calculator, 12 tangent of 30, okay? If you're going to do tangent of 30 first, that's fine, but you have to close the parentheses before you do times 12. Either way, I'm getting 6.93. Y is approximately 6.93. Again, that's the bottom. Now that I know the bottom, I can use Pythagorean theorem to help me find the hypotenuse. Okay, so 12 squared plus 6.93 squared equals, I'm going to use d this time, d squared. And again, I have on my calculator this already, so I'm just going to do squared plus 12 squared equals, get 192 for d squared, take the square root, and I get that d is approximately 13.86. So I go back to my original picture. My hypotenuse is 13.86. The base is approximately 6.93. And I think I now have everything I need in order to find both area and perimeter. So we're almost done with area. We've got the triangle area here, the rectangle area here. We've got to do this triangle. So area is the base of 6.93 times the height of 12 divided by 2. Okay, so here's my 6.93 times 12 divided by 2, and I get approximately 41.57 for my area. Okay, so of course, if there are 3 area parts, I need to add them together. I'm going to put that right here. So the area is 22.86 plus 300 plus 41.57. And when I add that together, I get an area of about 364.43 square feet. Okay, so the area part of my problem is done. All that's left to do is the perimeter. Okay, so I'm going to be very careful. I have all the parts I need. Okay, I do have all the parts I need. I am going to write this in. 30 is the top, so 30 is also the bottom of the rectangle. So I'm going to kind of do two things at once. I'm going to use my highlighter. I'm going to start. It doesn't matter where you start. Maybe I'll start here. Okay, that is 12.86 plus, I'm going to go around this way, 30. And so for a shape like this, that's a composite shape and it's got a lot of parts to it, this part by itself is just 2. The reason I'm highlighting it is because I want to know where I start and end. I don't want to forget. Across the bottom, 6.93 plus hypotenuse, 13.86. Plus it helps me visualize I'm only using this piece, not the entire part of that triangle. Across the top, again, is another 30. So I have some space here, add 30. This hypotenuse, 22.95 plus 22.95. And the bottom, that brings me all the way back around the perimeter of the entire shape, is plus 2. Now remember, if it's perimeter, I don't use these little yellow or pinks. I only use the parts on the outside. Okay, like if I was walking the perimeter of this crazy shaped building, how far did I walk, kind of. So here we go. This is where you just want to be real careful on your calculator. So I have 12.86. I'm just verifying, I'm looking, plus 30, plus 2, plus 6 point, see there, we got to watch, 6.93, plus 13.86, plus 30, plus 22.95, plus 2. And my perimeter is approximately 120.6 feet, okay? So I know that this is complicated and it's crazy, but remember our strategy. Break it up into shapes that we know, including right triangles, okay? Use your SOHCAHTOA to find the missing parts. Label as carefully as you can as you're going through. I think when I did this the first time, I used like 6 colors. I know I go nuts over colors, but I think it really helps stuff stand out and match it up to your newly drawn shape compared to the one on the paper, okay? So we broke it up into 3 shapes. We found all sides of all 3 shapes, and that helped us both with area and perimeter.